Hello and welcome to today's episode of Industrial Plumbing in an Old School. Must need my head seen to. Anyway, I've been planning this now for a few weeks. Those of you watched before, you've seen the lead up to this. Well, this is it. The jet stream that was holding us in the grip of minus 25 to minus 30 is released, and we've got warm air now from the south. So today is the first day where the temperatures have lifted sufficiently far enough I feel comfortable with switching off this quarter of the building. So if you imagine a big block, a square block, and the heating system is split into quarters, 4 quarters. In order to do the plumbing I need to do, and this is preparation for inserting an additional 2 radiators, I have to shut off one corner of the building. The pipes above me, these were all cut off and severed in the 80s. And I've reconnected them, and it's got partially part of this quarter working again. Now I've got to turn them off, which I've got a couple of valves. One's hidden behind my makeshift thing I'm about to show you, and then we're going to drain this quarter down. Now I had to make some big sacrifices in order to be able to buy the glycol that we put into the system to stop it from freezing even when it's on specifically this end of the building, because the pipes actually run through the concrete walls of the cellar, and once it drops down to below minus 25, even with the heating on, it can and has frozen the pipes. So it's now got sufficient glycol in there, which means I have to save every drop that's coming out. I'll show you what we've got going on in preparation for all this. So, I mean, quite noticeably, this valve here is flow, shut off. This valve behind this thing in there is return, shut off. Now I reinstalled all this. I don't need to worry about the flow. I'm going to disconnect the return pipe there and drain down the entire quarter. So because I'm doing this by myself, I've got some wire wrapped around a funnel into a new piece of pipe I've had lying around for years. I've left the plastic on because it's going to be lying around for years after I finished it. And then I've got a whole array of buckets. So I've calculated I've got about 45 litres in this quarter, because it's just a small quarter at the moment. I'm going to expand that 45 litres to the best part of 90 litres. But what I need to do is capture everything that's coming out. So I think I'm quite prepared with buckets, containers, a mop, a ladder, and everything that I should be able to do. I'm going to crack this joint here and start draining it. And so that I don't stand here for hours holding this up. And of course I can't be holding this end up and changing the barrels. I've concocted this system here which will allow me to be able to operate down here, change these barrels for these buckets. And hopefully when all of these are full, I haven't got to jump back into emergency mode and reconnect this because I haven't got enough buckets. And I have actually got some more containers around the corner there, so I think I've got enough. This radiator here is also attached to this corner. So yeah, these pipes go on through here, they come through here, and then they tee through this building, and it's here where they've frozen in the past. You see, they go into the concrete walls of the cellar, and when this wall gets so cold, they freeze, which is not good. So that's what we're doing. You'll see here I've also reconnected all of these and put in new plumbing over the last year so that we can put downstairs. This is where all our food prep, fish and pigs and stuff like that is done. How are the chickens doing? Yeah, they're happy, they're having a rest. Happy chickens. Right, let's set you up then. Crack this pipe off. So these valves are now shut from the main system. So the main system is in operation at the moment, but I've got 4 days according to the weather forecast where I'm in my safe zone. Right, let's connect you up. I think we've got that somewhat under control at that speed, albeit it might take a while. So we can see here I've cracked that. Now, that's going to take some while to empty 40 litres. However, if I go back upstairs now and then open up the vents to the radiators, that'll stop any vacuum occurring up there, and that's coming out at such a rate as I can feel comfortable to leave that emptying into that barrel while I go up and crack open the bleed valve. Okay, so this is the highest radiator. When I open this, it sucks air, not water. That's good. So that's the only radiator of any importance we're going to lose there. And then that's coming out quite nicely. So I'm not going to bore you all with how long that's going to take. We'll come back to this once that system's empty. Well, I didn't bore you with the fight of getting that out, but if you have a look at the kind of tools I've got lying around, you can see what a fight I've had to get that one out. Anyway, that's out now, so now it's time to insert that and that. Don't lose those. Don't lose those. We'll be in a right load of trouble if we lose those. Right, put those there like that. Okay, so we're going to do this corner first, and we're going in that way, and then I'll tell you what. All right, okay. I thought for a moment that might not be the right thread, but it is. So that goes in that way. Right. Yeah, so this has to go in that way. Better just make sure before we... I'm going to split it down. All this one-handed stuff, can't do it. Let's just make sure the threads are right, yes. Right. So now it's time to insert these two. So you've seen this gooey stuff before, and the rope. We use some of that, and we use some of that, and we'll put these two lower sections in first. What I might actually do is put this one in first and then attach this up, and then we've got to go up. And I've written on there flow and return, so that one goes to that one goes to that one, and then we know what they are up the top. Put it on this thread as you've seen me do it before. We use a screw to push it into the thread. So this is the worst kind of plumbing, steel. There is, however, a distinct advantage to it, which, in case you haven't already worked out, is it will burst when it freezes, but it has to freeze bad before it will burst. And I don't have the threader and the cutter and other valuable things that I could do with, really, for when this goes wrong. But I can get hold of the fittings that convert me from steel to copper, which is what we use. Right, so it's interesting to note on these, the lower thread is tapered, which is what seals it off. It is a tapered thread. I'll try and remember to do this in front of the camera. You have seen me do this before. That's that one done. It's tightening down the bottom. That's screwed all the way down on the thread. Where's the other one? So that's how long it was. So that thread goes all the way up till it meets the top pipe. And then this nut is screwed up. So that's the first one done. Something I learned from that one is because this is a tapered thread at this end, it's going to go in there a lot easier than the straight thread at this end. So what we're going to do with this one is we're going to put this end on here first. I've taken that back off there and opened up the gap on that particular pipe. And the reason I've done that is because I was all too aware that this pipe here is going to go below the level of the floor. So you can see I've already had to cut a piece of the floor out. And I have to get these on top of those pipes. And if you remember from my last video on the plumbing side, these are fittings that allow you to go from steel pipe, 3/4 inch, to brass. And they have a locking washer with a rubber seal in there. So we want to actually install this on this pipe before. This pipe on this side, I can't remember whether this is flow or return. This is already at the right level. So we're good. We're good to put that in. This washer, rubber washer, needs to come up. A nice splinter in my finger there. And then this needs to come up and seal onto there. All right, so having raised that first pipe, I've had to drop it so that I can get this Mahuza spanner in there on there. Now raise this back up and put the other fitting on like that. Now this one's not got to move again. This one, however, I've got to screw it up. So quite how we're going to fare with that, I don't know. I'm not sure how that's going to work. But all I do know is it's going to be a lot better than trying to get in down there to do it up. So now at the top, we've got this scenario. Not particularly favourable, but not a bad one. So we've got these other fittings. We're going to come out of here and use a compression fitting to come out of here. We've got these taps to put in, and then we're going to come out of here and use a compression fitting onto here, then put taps in this corner. And the reason I'm putting taps on this corner is it's a lot easier to disconnect various radiators using these roller balls in this specific situation. In addition to this, I know I'm going to change this radiator for 2, and the radiators need coming off for decorating because this is room in progress, and the walls behind the radiators need decorating. So it's a lot easier if I can disconnect in this corner with roller balls and drain the radiator and take the radiator off than going through the scenario we're going through. Right, let's go and make up what we need. So this is what we've got for up the top. These screw into those brass 90 degrees. This is a 22mm to 15 reducer. And then we want 2 bits of pipe that long. And you'll notice deliberately, whilst I've already had a fire here, look, and fresh sawdust. The paper, fresh sawdust, MAP gas. And a bit of pipe that long. So on these, with the brass, so on the brass, I'm using Loctite 55, which is a cord, which is a thread cord. It seems to work as good as the messy stuff on the brass to brass. Let's get in there and do that up. Oh, I've managed to squeeze that lot in there. So we've got the steel pipes coming up through the floor, and then this first big brass sleeve, which is steel to brass, brass 90 degree, copper 3/4 inch, 22 to 15 reducer onto a 15mm compression 90 degree. Not ideal, but probably the most suitable thing for this application, and we've got exactly the same on the underneath. Coming out the brass fitting with a 3/4 copper 22 to 15 reducer, 15 on a 15 compression, coming out to a 1590 solder joint into 215 taps. Now, I wouldn't normally put taps like this within the room, and certainly not on a radiator. However, as I've explained, that radiator needs to be it's temporary. Pretty sure it came out the skip. It's not decorated. This is going to have to come off again. With these taps now, I can turn the central heating off here and just remove and empty the radiator without having to drain down the system. And all this lot is going to go back in and be insulated and housed back in the wall. So you won't see any of that. All you'll see is the copper pipes coming out with the 2 taps. The other advantage I think I've got, because I've got all these compression fittings on screw fittings here, is I should actually be able to fill this with water, turn the taps off and pressure test it here. Not that there's a lot of pressure up here, but we just don't want any leaks in there. I've used compression fittings here because whilst this wall is not full of sawdust, the wall behind it is, and the floor is. And I've already had 2 fires inside the walls and under the floors now, as a result of plumbing, when we're just not doing that. Right, that's top side done. That'll get this radiator a lot hotter than it's been before, and it'll give me more control over what I'm doing downstairs. Right, we're back down here now. So the object of the game here is to get these pipes outside what will be the false wall. Alright, so that's my spare off for the new radiators in this area, and I wouldn't have normally done this, but it's going to be behind the wall. These will be exposed as the copper pipes come out, so all that will be inside a cabinet. Okay, well, I think now I have to go back and do up the bleed screws in all the radiators. Then we can go downstairs and we can start filling the system. yeah, I think that's it. I think we're done. So I want to show you what I've managed to reclaim. So I can't go out and buy new materials. So I'm forever finding intuitive ways to use or reuse. So that radiator upstairs that we just plumbed in from the side, 2 years ago I plumbed it in from the other side of the building. And this is all the pipe that I've managed to reclaim. And I don't think this pipe was new then. So this pipe was new 6 years ago. And it's been used and reused and reclaimed many times, where I have to do temporary plumbing around the building to solve a problem immediately because of a situation, knowing that ultimately I'm going to resolve it properly. And that's part of what we've been doing with this, is whilst it needs another radiator in this area down here, the top radiator under that big window, that's been temporarily plumbed from the other side of the building for 2 years, and it gets barely warm. It's just what we're doing now, we'll heat it up. Anyway, so that's my reclaim. Everything's reclaimed and used again until there's nothing left of it. Right, let's go and shut those radiators down. Should have been filming while I was doing that. Those that have been here before, you've heard me say many times, everything breaks, all the time everything breaks. Well, I was doing the bleed nipples up, minding my own business. Well, not only is it broke, it's cleared off. Anyway, another job. Good job I got some spares, isn't it? Right, as we were then. So air always collects at the top of the radiator, so you can undo that, let the air out, and there's a little hole in the back, and air comes out until you... There's a look behind the scenes, look. There's a room that's been in progress now for 5 years. We haven't progressed very far in here. We needed to get a radiator in here, so we got up a bit of plasterboard and plumbed the radiator. I can see something glistening down there, can't I? No. So, yeah, this is the inner workings of an old school. And then plumbing. New plumbing. New drains, because the old ones were cast and broken. Oh. Anyhow, that's a bleed nipple air release valve. If you don't want to use the word nipple, I like the word nipple myself. And then there's another one on the end there. And you can see the mess I made. See all this black stuff? Oh, I done that. Can't even tell you what a mess I made. Right, and then we're back over to this corner where we've done that, and we've got those locked off. And then we'll do this. So I undone these to allow the air in. Fiddling about with these things to allow the air in to allow the water out. Right, we can go start pumping now then. So the other thing I had to do was this radiator on this side. This was where the other radiator was connected to, and all I've done is cut off the feed that ran along under here and left it like it is, because this is not the right radiator. This one here is not the right radiator for the original pipe work, because this radiator rusted through and leaked on the floor where it had been sat empty for 50 years. And I'll tell you what I mean, because up this end of the room there's another radiator that's disconnected. This one also rusted through, and I'll show you what rusted through looks like if I can find it. Somewhere under here, the bottom of the radiators rust through on the fins, and they just, oh, it's up there, you can see the rust. They just start leaking. And whilst this room, you can see the sawdust everywhere. So this radiator, this doesn't work now. This blew out 2 years ago. So for the size of the room, you can see the problem I'm having. Anyway, so I've reconnected that back up there. So I've got to check the joints on that. But this radiator here also fed that radiator over there. So that copper pipe I've reclaimed was from all the way down here. Now, there. And that's another repair I've had to do because this radiator came out, I think it came out of the skip or somewhere else, maybe another building. So, yeah. Anyway, now I've got the taps on there, I can take this off for when we get to this room. And we're going to put 2 radiators in here and obviously take all these off and paint them. This radiator here, we're probably going to have to find 2 matching radiators for under this big window. And then this radiator here will go back over and replace the broken radiator over there. But everything's in such a mess because this is be one of the last rooms to do, as you can see. So this is where we're stood now, is originally where the old bedroom was. So you kind of, this room, I open this, anyway the video's coming for that. We're on plumbing today. Okay, what have I done with them radiator keys now? So here we are, back where we all started, ready to do that nut up there. How did we do? Well, you can see the water's still flowing. And about 16 hours after I cracked that open. So we can now do that up and go and get rid of this. Was there a big mess overnight? Oh yeah. 2 big messes. Alright, so here we are, back in the furnace room. Now, for those of you who've been here before and watched the previous plumbing one, do I put a link up there? Now it will start to make sense. So, quite clearly what I was doing, whilst most people understood what I was doing, some people completely missed the whole point of what I was doing. And this is the point of what I was doing. So, it's impossible for anybody to get into my head, which is a really good thing, and therefore it's impossible to know all the forward plans and what's and why fors. Here's the forward plan, now we're in the future. Now, the only way to get all that, right, which looks like a lot of dirty old water, but is really, really valuable, the only way to get that back in the system is to go upstairs with a micro tube and a funnel and open up one of the radiators and start pouring it in. 20 days later, you might have managed to get 80% of it in the radiator and the other 20% all. I've been there, I've done it. I don't have to do any of that. Right, now, we have a huge funnel and a tank and a pump and a battery. And all we have to do is open up the main heating valves and start pouring that lot straight into that tank, and that little pump's going to do all the work, and we are going to have 0 waste. Now, what's this? Wire wool. Why have I got wire wool? I can't tell you the amount of good uses there are for wire wool. Wire wool, a 9-volt battery, a couple of wires, a bottle of acetylene, and some plastic bags. Man, I can't tell you. Anyway, it also makes just about the best filter I know, the microfilter. So I'm going to push that in there, and that will take all the muck out of this horrible water, and it will clean it, but all the chemicals will stay in it. So, this is our pipe down from the header tank. Water. Take that out, put that in there, put that in there. What we want to do now is pump until we've got water coming out of it, and then we can go and open the main central heating valves. And what that'll do is that will immediately take the water out of the heady tank and start filling up the system that we drained, whilst we continually pour this in, and then we'll have to go around and bleed the various radiators and keep pumping up the system. Now, I've added or taken away, we're not going to be far short of all of this being the right amount, but what we want to do is end up with an almost empty tank, and then we're right. So we might have to add some fresh water, which we can do with that tap, or we can just put it in there. So first thing to do, I guess, I'm assuming this has got water in it. Yep. That's about a third full. Okay. Now every time I look at this camera, the light that's on it blinds me. Okay, so you remember that's a pressure pump. Once we open this, it starts pumping. Right. Let's leave that going until we've got water coming out of this end. So while that's running, here's a little tip. Fly traps, wasp traps, bees shouldn't trap bees. But anyway, things that are attracted to sweet stuff. So there's like sugar and water and honey and all these other things that these things like. A little known fact, glycol antifreeze. It is so sweet. It is unbelievably sweet. Now, I don't know to what extent. I do know it's highly dangerous and poisonous, but apparently they use it in food. Just don't even want to think about that. Anyway, so a little bit of antifreeze, coolant, because it's so sweet and nice smelling, the wasps and the houseflies, they just go straight to it because they think they're drinking something sweet. Kills them real fast. So the first place we're going to see any leaks is here. This is the lowest spot. Right. We've got hot water there on the flow. So that means this should, oh yes, there we go, we've got water there and we got water there. Okay, no leaks, so we're good there. Hot water. Now we don't have any hot water going up there because we haven't opened up those valves yet. Then we do the same to this one. Only what we don't want to do is spout dirty water all over our nice painted walls. Right, that's that one full. To see if we've got any leaks, any sign of any water. No. So when we open those valves, that'll send water to the new radiator. So then what we do is we go and let the air out of these ones, because these are still not the highest ones. Right, so we're back down here. Nothing running out of there. Check our water level in the tank. Make sure we're not about to run dry. That's about a quarter of the tank. And we need to keep running that and filling that now until that runs out. But we want to try and keep this tank as empty as we can, but not run it dry. Because if you want it dry, you've got to bleed the pump up. And then we'll be good. Then our header tank upstairs will be full. This will be empty. Everything that I've done will be back and working. And we would have got all our chemicals back. Okay, so that's the header tank full, and that would normally go to drain, and now it's going into this tank. I've got a water level of about here in this tank. That's exactly what I want. I can shut this valve here, it switches the pump off. I can now disconnect the pump because we no longer need it. Wow, that was easy. And that will continue to flow for a minute until it empties out all its overflow. And then it will overflow some more when we heat the water up. So that's exactly what I wanted. That's the header tank full, the entire system full. All the radiators are now hot, no leaks. The extra spares there ready for the 66th radiator. 67. Still not finished, still got more to do. There's rooms down here that have got no heat. So, well, that just made that so much easier. The pump, the tank, the refilling of the system. As I explained before, I probably only got to turn that on once or twice more before the end of the winter, and that's just to top the system up a little. The header tank is just not going to empty. So easy, tidy, done. Plumbing a success, no leaks, everything works, everything's filled back up. Great. And I think there's another 2 warm days before we plunge back down below -20. I call them warm. How's the furnace doing? Yeah, great. Everything's great. So that's the end of that one. Thanks for watching. If you enjoyed the video, remember, give it a thumbs up. Subscribe if you're interested in this kind of stuff. I say this kind of stuff, it's so varied, it's unbelievable. Thank you all for joining me. It's very much appreciated. Bye for now.